Hi, everyone. I just want to weigh in on Module 7, where we're talking about balancing between problem-based learning and getting the basic facts, right? So I'll give you an example. Um, so I, I've now, for the first time in my career in the last 2 years, had to, and really enjoyed, working with K-5 teachers. Um, an example that comes out of that that strikes me as really interesting is that basic facts for students would be different. So not everybody has the same set of basic facts. For example, um, s- some students use multiplying by tens as their basic facts and then work from there to multiply by 8, for example. So they'll do, so to do 9 times 8, or to do 7 times 8, they would do 7 times 10, and then take away 2 sevens to get to 7 times 8. And they do that fairly quickly in their head. And then eventually 7 times 8 becomes a basic fact. So that idea of using mathematical intuition to develop basic facts for yourself has been new to me in the last 2 years. So what I want to show you is a couple of resources that range from, I would say, heavy PBL, problem-based learning, to something that I would consider really good practice for basic facts. So I want to show you kind of those two ends of the spectrum. And again, they're both on my resources page, which I'll give you the link to at the end of the video. So this is one of them. This is Robert Kaplinski's work. I'll show you the main page in a second. But the question is, how big is the 2010 Guatemalan sinkhole? So there was a sinkhole in 2010 in Guatemala that was caused by water runoff. And the question is, how big is it? And the thing that was really exciting about the sinkhole is that, it was very extremely cylindrical, which we can also bring in geography as to why that is. Students are asked to estimate the size of the sinkhole. What do you think is too low? What do you think is too high? And then what information do we need to figure this out? And then as students ask for the information, we can kind of give them better and better pictures and images. So here they're comparing the size of the sinkhole to a shadow of a helicopter. Here's a close-up size that has a one-story building that they might be able to compare to. So lots of different ways for them to estimate. And then there's even a video that dives down into the sinkhole so that we can see the depth roughly. So that's a lot of work for students to kind of think through and to estimate and to use their mathematical intuition, and then to finally use the formula for the volume of a cylinder, right? So that's one idea. And I'm just going to show you what his page looks like. Nope, I'll show you a different way. So here's another example. And so this is a step back from that big problem-based learning idea and looking back at basics, but looking at it in a, I would say, much more interesting way. So this is what's called an open middle problem, where we give students some kind of structure, and it usually has the directions use digits 1 to 9 at most one time each. And so in this case, they're asked to create an equation where x has the greatest possible value. Right? So you can see that in order to do this, one, a student would have to solve a whole bunch of equations. So this is their practice. And then they would also have to reason out, well, for this to be the biggest value, what do these two things have to be? So this might have to be really small and this might have to be really big, or whatever their idea is. But I'd want them to kind of think through that. And once they're done that, I would want to share solutions and I'd want to share reasoning. And it doesn't just work for equations. Here's another one, Pythagorean theorem. So use the digits 0 to 9 at most one time each to fill in the boxes to find two pairs of possible lengths. So I want a length and a hypotenuse that would make this work, and then ideally another length and a hypotenuse that would make this work, right? So again, students are practicing Pythagorean theorem, but in a much more engaging, thoughtful way than just solving equations. So again, open middle problems are available on my Engaged Thinking resources set, and also Kaplinski's problems are available there. And when you go to Kaplinski's site, this is what it looks like. It's organized from, K to 12, but it is American curriculum, so you would have to just kind of make sure that it fits your curriculum, which I think is a worthwhile exercise all the time. Okay. So in the end, my take is that we need both. Practice as well as rich contextual problems, but I think the practice needs to be done in more meaningful ways, because if we give students a whole page of simple questions, then that's all that they're going to be able to do, and then it's hard to get them to think outside of the box of that simple problem. All right, thanks for all your discussion again. Cheers.